to this computer. I'm recording now, and I'm gonna share my screen now. Okay, everybody, can you all see my screen?
Yes.
Yes.
Okay, cool. So we're getting started. Right, I'll start from an introduction, starting from our Zenroom homepage. So when you land here on Zenroom.org, the first thing you read is Crypto Smart Contract Executor, which is for everybody working in blockchain or cryptography, they might guess more or less what it does, but in reality, it's a very exotic thing. And until a couple of months ago, this line wasn't Crypto Smart Contract Executor, but it was Crypto VM, virtual machine, which we had to change because everybody was asking if we were competing with VirtualBox, which we actually are not. So we changed it into this. I'm gonna give you a very quick walkthrough of the main features of Zenroom. Let's starting from how it's built. So Zenroom is coded completely in C, meaning that we have builds for Linux, Windows, Mac, Android, iOS, and very important WebAssembly. WebAssembly, for those who are not familiar with it, is a transcompiling process that's from source code in C, C++, Rust, and yeah, I think that's it. From C, C++, and Rust, code gets transcompiled in a file called WASM, which is interpreted and executed by a virtual machine built in a browser, which in the past couple of years has become a standard, pretty much like JavaScript. So the Zenroom build, the WebAssembly Zenroom build can run inside the browser. We actually tested even mobile browser, so it runs wherever you want. So we have builds for Linux, Windows, Mac, Android, iOS, WebAssembly. We have made experiments on Cortex-M chips, so on very, very tiny IoT device, and it supports very tough computer security. The payloads, so the executed binary is usually around 1 megabyte. It uses very little memory. So with 300Ks, you can do most of what you need. And with 2 megabytes, you can do all the cryptography you want. So when it comes to cryptography, what does it do exactly? We can do different types of cryptography, both old school as well as more modern. ACDH means asymmetric cryptography. This is asymmetric cryptographical signing. Then we can do more advanced cryptography with elliptic curve pairing, which brings to the most modern stuff, which is attribute-based credentials and zero-knowledge proof, also called ZK snarks, which are based on a cryptographical paper called Coconut that was developed by some guys who have been acquired by Facebook to develop Libra. So we do have the first and possibly the best implementation of the cryptography that's on which Libra is built on, which comes from this paper. Then a major effort in developing Zenroom was put on determinism, which we have extensively tested. So when I say determinism, means that given a certain seed, I can be sure that a key pair will be generated in the same way. So the generation of a key pair will give the same output on any device I run Zenroom on. The same thing will happen with a signature, with asymmetric encryption. And because of this, we call scripts that are executed by Zenroom smart contracts. because of the determinism that Zenroom can assure when a smart contract is executed. Last but not least, and that's what we'll be mostly working on, Zenroom can be fed with scripts in Lua, as well as in our native, well, in our in a domain-specific language that was developed by us called Zencode, which is non-Turing complete, meaning that you cannot do whatever you want. You cannot do a for loop, you cannot do an if, you cannot call a function that is outside a different script, but it is English-like, meaning that the language has been designed to be written and read by non-programmers. We didn't use, we initially were thinking of using the definition of natural language-like, but that didn't really fit because the syntax of the language is very strict. So you can't just move the words around and the language will the software will understand it. Nonetheless, the scripts are readable by non-technical people, non-programmers. And this DSL is called Zencode. It is heavily inspired by BDD, which is behavior-driven development, and a security group called LangSec that that influenced the way the Zenroom virtual machine goes online. Okay, so that was my introduction about the software. I will not tell much more about the features and the performances. What I would like you to do is, if you scroll down here, you can get the source code, which is on GitHub. Here, the sandbox links to our new playground, which I'm going to show in a minute. And if you scroll down below, you get all the downloads. So the downloads are for the command line interface binary, which also we're going to see in a minute. We're going to look at Zenroom as a command line on a regular Linux box. We also have executables for Windows and Mac. Here you have a collection of libraries. And here you have packages with bindings for other languages. We will look at applications that use this one in a minute. Here we have extensions, and we're gonna cover some of them in the most advanced webinar. So here I open the playground. Here I open the documentation, which we have to go through quickly. So let me post some of the links I'm using here. So the homepage is Zenroom.org, and the documentation that we're looking at now is dev.zenroom.org. I hear some noise. Could you please, guys, mute yourself? Yes, thank you very much. Perfect. Okay. Okay, I'm gonna mute all of you who are not muted. Then when you speak, remember to unmute yourself, or just use the chat. Yeah, perfect. All right. So this is the beginning of the documentation. From here, you can get to the download page and to the online playground, which we're gonna look at in a minute. In the documentation, we look at some basics of Zenroom. So here we go a little bit more in detail about how Zenroom is built. So Zenroom brings online a virtual machine, and the virtual machine processes data in three phases: given, when, then, as inspired by BDD, behavior-driven development. Here there is the command line, but we're gonna skip this part for now. Now, actually, let's look at the command line. Yes. Let's look at the command line, because in reality, this is what Zenroom is mostly about. All right, I'll just run Zenroom from here without passing it any argument, any parameters. You just see what it does. It goes online. It tells me the version number and the GitHub commit. This one very important. It tells me that the curve it is using is this, and that is using 300K of RAM just for going online. The curve, this is the default curve with the build that we're using daily, but Zenroom supports a bunch of other curves, including BLS 383, which is the curve used by GitHub, as far as I remember. It uses Edwards 25519. Yeah, it's here. No, wait. Tests. Yeah. So those are the tests that we did to test the cryptography of various curves. So Zenroom supports this Edward curve. It supports Elgamal cryptography. This is a test to test the quality of the random. We can run it later in the advanced script. Yeah, there were a couple more somewhere, which I've lost now, but we don't need to look at that. So let's try and execute a script. Let's jump here from the quick start. Let's run it from a command line. Yeah, okay, so this should, the first script we run creates an array of 16 random objects of 32 bits. So what I'm gonna do is, I'm gonna copy this. I'm gonna go back to my shell window. All right, I think that I have it here already somewhere. Keeper.zen. No, I don't. Okay. Array random array.zen. I'm gonna paste a script here. X, yes. Random, this one. Then I'm gonna launch Zenroom. -z random array.zen, and this is the output I get. Let me try and make it better. Yeah, much nicer. So I asked Zenroom to generate a random array of 16 objects, 32 bits long, and it did this. Now let me try and modify the script to create 16 objects that instead of 32, they are, let's say, 512 bits. And I run the script again, and you see I have an array. Okay, run it again. With 16 very fat random numbers. Okay. Then here I have another script, which is called keeper.zen. Let's have a look into it. Nano keeper.zen. The script goes scenario ECDH. ECDH stands for elliptic curve Diffie-Hellman. We're going to go into scenarios later in the advanced part. Given that I'm known as Alice, which might as well be Andrea, when I create my keeper, then print my data. So you see here the given, when, then statements. We have I think that you only need to have the given and the then to run Zenroom. You don't need to have any when, but as a first example, we're giving you an example where you see one statement of each phase of the execution. So I'm going to save this. I'm going to run it and -z keeper, and I'm using JQ stands for JSON something, and it's just a JSON prettifier. So it shows me the output. It formats the output like this instead of a very long string, so it doesn't do any magic. Okay, I'm gonna launch Zenroom with the script I've just shown you, and here I have a keeper with a private key and a public key. So what do we read here? That Zenroom used, when it went online, it used 300 Ks of RAM, and after it finished the cryptography generation process, it had used 347. We can also, I think we can also see how long it took to do all of this. I think you do like that. Yeah, here we go. So the generation lasted around 0.05 seconds. If I try again, yeah, it's pretty consistent. Okay, so here I gave you a very quick demo of Zenroom as a command line tool, which is the way Zenroom was born. Very important to understand is that Zenroom brings online a virtual machine that is completely isolated from the operative system. It has no access to any function. It has no access to the time. It has no access to the file system, and it's stateless. So everything that Zenroom does is printing out the output to the standard output. If I want to save the output from a file, I have to redirect the output somewhere. I can do it like this: JQ, then I can do T my key pair dot JSON. So if I go here, I have mykeeper.json here, and I can do nano mykeeper.json. Here we go. Here we have my keeper. Right. 23 past 3. We're gonna go quickly through the online playground, and so I'm gonna show you some basic stuff. And then this session will overlap in the advanced session. And we'll go on after 3:30. Okay. The online playground, it went online a few days ago. It's called apiroom.net. I'm gonna paste it in the chat here. Okay, let me see how many we are. So we are still, hold on. Okay, how many people do I see? Okay, we are 14 people, including me. Fine, very, very good. So when you land here on apiroom.net, you're presented with this page. The first thing you should do is looking at an example. So you click on example, you pick the first one, which is the one we used before. Okay. And the very first thing we can do is press the play button and see what happens. Here we go. So here we have a keeper exactly like the one that I generated on the command line interface. And now mind carefully that this part of API room, so whenever I execute something here by pressing the play button, the computation happens inside your browser using the WebAssembly version of Zenroom. So this doesn't use an API or it doesn't do any query. Everything runs inside the browser. Also, we're also go into details about this later. Very interestingly here, if you try to play with it, try with typing when you see that we have this autocomplete function that shows you all the statements of Zenroom, all the statements that we have now, along with an example of how to use them. This, I think it was Daniel who asked me, Daniel who introduced himself as a non-programmer and is curious to see how far can you go with this without being a programmer. I think that that's what you should focus on. So you should start, you should get a grip of the given, when, then phases, then start playing with the autocomplete and see what you can do. So in this script, so right here, I'm creating a keeper, but what about, I also want to create some random number like we did before. When I create the array of 13 random objects of 256 bits, then of course I can modify. Actually, 256 was okay. Let's do 128, and here we do 10. So let's see what's gonna happen here. Bam. Since I am Alice, well, let's say I'm Andrea. Let's make it look more real. Right. Since I am Andrea, inside Andrea, I have an array, and I have my keeper. So notice that I have been creating objects here, and Zenroom decided itself the name of the objects that were created. So it created an object called array and another object called keeper. Keeper has to stay like this. You cannot change it because a lot of other functions inside Zenroom expects that when you want to use a keeper, it has to be formed this way. But we can change the name of array. I'll show you how we do this. When I rename the name of simple object to name of new object. So here I'm going to do, when I rename the name of array to Andreas array. Let's see what happens here. So look at this now and look at what's going to happen next. Here you go. So like this, I have renamed an object in real time while I was, well, an object in real time, and I manipulated something inside the script. Right. Then we have keys and data. First, I'm gonna save this smart contract. Let me see. I'm not even logged in. Okay. I'm gonna save this smart contract here. All right. I'm gonna use another window where I am logged in. Let me see. Where I am logged in as Dyne.org. All right. So same application, but instead of being incognito, I'm using my own browser window. So I'm gonna try the same thing. I've copied the smart contract. I'm gonna paste it here. I'm gonna press play, and the same thing happens. First thing I will do here, I'm gonna do it now and skip it for the moment, then we're gonna go back to it. I'm gonna save this smart contract. To save this smart contract, I have to press the button Create API. Yeah. All right. I'm gonna press the button Create API. You probably don't understand why this button is called Create API right now, but we're gonna get into that in a second. And this we're gonna call create keeper and random array. Right. Okay. Now let's have a look at keys and data by using a different example. Oh, this cut. Found a bug. Nice. All right. Let's look at encrypt a message using a password. So this example populated the scripts here along with the two text boxes where you enter data. Here, the one called keys, here we have a password. And the one called data, we have 2 strings, one called header and one called message. So in the message you read, "Dear Bob, your name is too short, goodbye Alice." Very funny. It's 3:30, 3:31. So I think that as I go through this example, we're done with the start part and we can officially kick off the advanced part. So we're gonna take a little break and see if there are questions. All right, so let's go through the script. The script starts with scenario ECDH. Then I have 3 given sentences where the first one says that I have a string named password, which is actually here. The second one says that I have a string named header, which I find here. The third one says that I have a string named message, which I find here. In the when phase, which is where the computation happens, the statement says, when I encrypt the secret message, which happens to be this object here. You don't know, but you don't need to know this for the moment. When I encrypt the secret message with password, then print the secret message. This is a little bit confusing right now, but it's very well explained in the manual. If I press play, I get as a result this object, which is the encryption of this with this password. All right, 3:32. I think that we can take a little break and ask if there are questions. Everybody's muted, so you have to unmute yourself if you want to speak.
Hello, I have a question.
Yeah.
So basically, as I understand, it's a virtual machine that restarts, kind of like a Docker container every time that I want to restart it, right?
Yes.
So then if I want to store a smart contract and I want to kind of keep track of what's happening, you already mentioned that it's stateless, but how can I make some kind of extrinsic calls to it or to some kind of storage, or that isn't really in the plan? So
it is in the plan, is developed, and we'll cover it in the advanced part.
All right. Okay.
We didn't get there yet.
All right. Okay. Then I'll wait.
Sure. Okay. Anybody else?
Yes, I have a question. Is it working with Ethereum, your platform?
My platform. So we have been making experiments with the Ethereum curve. I would say that Zenroom can do the cryptography of Ethereum. So it can read a block and write a block, but we haven't done any work on a transaction processor.
Okay.
So it could work with Ethereum with a little bit of work.
So it is in your plan to be compliant with Ethereum and also other blockchain platforms, I imagine.
So we already have everything that is needed to do transactions, so to read and write data to Bitcoin and derivatives. Then we already have and is fully proved with Sawtooth, with Hyperledger Sawtooth, and with Tendermint. With those 3, we can read and write data already. So read and write data means that Zenroom can do the cryptography needed to read and write the blocks. And we also have a transaction processor that sends the block onto the chain. For Ethereum, we don't have the transaction processor yet. But okay, if someone needs it, then we're happy to talk about it.
And you are able to perform smart contracts using Bitcoin.
Say it again.
You are able with Zenroom to run smart contracts using Bitcoin blockchain.
Theoretically, yes. The problem with Bitcoin is that you only have 80 bytes to store. Yeah. Theoretically, yes.
Okay.
But I mean, it depends on what do you mean smart contract. What we can do is, for example, we can build a side blockchain using Hyperledger Sawtooth onto Bitcoin. Onto Bitcoin. so that the smart contract is executed on a side blockchain, and based on that, value is transferred in Bitcoin. That we can do.
Okay.
Which is a little bit what Polkadot is doing as well. So building a side chain. But yes, we can. So if for smart contract, you mean that at some point something is triggered and it pulls some data somewhere, it does some computation, and if the output is yes, then it transfer value from a wallet to another on Bitcoin, that we can do.
Okay.
That we can do.
Good.
But if you're thinking about building Zenroom into the Bitcoin wallet, that is a different story.
Mm-hmm. I understand. Thank you.
Welcome. Okay, more questions? No one? I'd like to hear some feedback from Daniel, who's not a programmer. How scared are you so far about this? About what I've been doing so far?
I mean, I get some things and others I just completely don't know about.
Okay.
So
I guess that the cryptography is the part that you understand less.
yeah, for me, this is the question. I mean, the cryptography I don't understand.
Yeah.
And, but also from when it comes to the point, okay, on what stage is that people can take this further to an application? Like, is it like in a? I mean, I see that as still a work in progress, and I mean, is it something that is really always given for a programmer, or is it going to be much more handleable as for a lay person, you know, to connect different cryptocurrencies, different contracts, and make contracts even like, yeah, just with people that have their own basis.
So by your sentence, you're asking if it can only be used by a programmer or also by a person. So you're implying, with reason, that the programmer is not a person, which I completely agree with. I can't really answer you with a sharp answer. I guess that if you go further, if you keep following the demo, I'm going to show you a couple of examples where you can pull data and manipulate data quickly just by using this tool. But if you expect to be able to move value from cryptocurrency to another, we are not there yet, but we're not building a cryptocurrency wallet. This is a component that powers cryptographical tools. So a crypto wallet can use this, or a developer developing a crypto wallet can use this to accelerate brutally his development cycle.
Yeah.
This is what the tool is about.
Yeah. Okay, got it. Yeah.
And when it comes to the contract part, you can execute operations with something that reads like this, and you may need a little bit of training, but it's not like programming C++. So for C++, you need 1 year. For this, you need a week. And after a week, you can for sure read, and you can probably write something, and you can manipulate some data. Then obviously, if you want to do cryptography, you need to understand cryptography, but that's a different story.
Yeah. Thanks.
Cool. Okay. So now we are officially jumping into the advanced part. We have seen 2 examples in the front end. I am gonna jump to what we call the back end, which is this, where we will see the smart contract that I've said before. Okay. All right. So those are scripts. Oh, my mouse just died. Little break. I need a little time. Yes. All right, so here we have 4 smart contracts. That this one is the one I've just saved, while the previous one were saved before. So when I introduced you the 2 smart contracts in the previous example, you probably remember that the first one I had didn't have any keys or data, while the encrypt with password, which we've seen 5 minutes ago, has stuff saved in keys and data. Okay, in data we have here. So when I saved this, I pressed the create API button, and I'm going to show you now why. Because if I click on this link, you can see already where the link points from the bottom left of my screen. If I click on it, I'm going to reach that page and see what's going to happen. Here we go. And this is something you can do from your browser as well. So I'm going to paste it to the chat. Can you all see the chat here in the Zoom window?
Yeah.
Yeah. All right. So if you click on that, you should be able to get this. And I'm going to do something else. I'm going to modify this in real time. Well, no, not from here, actually, from here. This one. I'm going to modify it here. I'm going to create 1 more of those. Of, let's say, 3 random object of 32 bits. Let me save it. All right, it saved it. Let me refresh this page. Yeah, so you see that now I have 1 more object. And if you execute it again from your browser, you will see that there is 1 more object. So very, very important to understand what happens here is not the same thing that happened here. Because here the computation was happening inside my browser, while here it's happening server side. So here we are actually using a microservice that you can call using a REST API or just like this. Did you all get this part? If someone is lost, let me know now and we go back.
No problem.
All good? All right. Yes, then let's look at the encrypt message with password example. So once again, in this script, I need to have 3 strings loaded. 1 named password, 1 named header, and 1 named messaged. And here we have a string named password, which is my very secret password. Here I have the 2 other strings, header and message. We have a red dot here that tells us that what is stored in data will not be passed to the API. Only what is stored in key is being used. So if I try to run this API now, I'm gonna get an error. Actually, the next version of this application is gonna show you the output error in a nice way. But anyway, the error was this. Zencode Lua, given that I have a string, error detected, execution aborted. So Zenroom cannot find this string name header, simply because we're not passing it. We're not passing into it. How can we work this around? We go to the test API button. Test API brings online an instance of Swagger. In Swagger, we can debug and test all the APIs we created. So in this case, we're working on this one. Encrypt with message and password. I am presented with this. I click on try it out. And what I'm gonna do, I wanna pass it some data, so I have to write something here. So what I'm gonna do, well, first of all, I'll execute it like this, so that you see exactly what happens and the error message that it's giving to me. Yeah, so here we go. This is the complete output of Zenroom. This is the script. Zen call Lua 285, given that I have a string header, error detected, execution aborted, bang, stopped. Good. So in order to make this work, I have to pass Zenroom this data here. I'm gonna copy. And I have to paste here as a JSON file. So I'll simply overwrite this, okay? I mean, whoever is familiar with JSON will know that this is that's the format to pass data to pass. That's how you write a JSON. So I click on execute, and I have my output. Right. Swagger does something else. It also provides me a curl script to call this API and pass it the data that I passed it, while this part here, so this this key is gonna be passed it from behind, so you don't need to worry about it. So what I'm gonna do, I'm gonna copy this curl post, and I am going to paste it into my shell, my terminal. Oh, come on. Which is this one. Let me make this a little bit bigger. Change settings. Appearance. $14 should be fine. Actually, maybe it was a little bit too much. Right. Okay. So I'm gonna paste here what I just copied here, like this. Ah, wait. Let me try again. Copy. Yes. Curl -x posts API-room.net, and then I pass it this data as inline. Press enter, and I get my encrypted secret message, which looks a lot like this. Because of the type of cryptography, there is always a random factor. So the checksum does not look the same. The header looks the same. The IV does not look the same, and the text does not look the same. The header is actually, it's only signed, while everything else is encrypted. And with those, so this encrypted is encrypted. This is the checksum of everything. And with here, because of the cryptography used, you have a certain random factor. So if I run it again, it's gonna again look a little bit different, but the message can still be decrypted. If you don't believe me, I will show you. If you want, I can also show you how to do a curl with a file. So basically, instead of passing it this stuff here, I can do, yeah, actually I have it in the manual of API room. Hold on. Here, I can go and open the manual. And in the bottom, we should have instructions about curling from a file. So what I want to do is I want to save this onto a file. nano my no file to curl.json. No, data to update, data to upload.json. Yep, Control X. Data to upload, it's here. Then I use this string for curling. Nope. Curl with the file. No, sorry, this one. This one, I will have to adapt the name because it's not in the JSON. So let me, yeah, this didn't work because I didn't pick the right file. Now I'm gonna change this, and what was it that I called it? Data to upload.json. So this is gonna be data to upload.json. Now it should work. Yes, here we go. So back to Daniel. Maybe this is a little bit too much for you, but you can prototype a, not here. You can prototype a service here, a microservice, and then you can pull data from somewhere and re-upload it to the service and get an output, which you could use to do quite some stuff. Basically, you can't put together a service like Twitter, but you can use for quite some stuff. Right. So, did any of you land on apiroom.net? If you did, you probably have noticed that you have to log in, and you don't have a login. In order to log in, you first have to sign up for a new account. And when you sign up for a new account, you write your name, your password, you repeat the password, and then you need a secret code that only myself know. And now I'm gonna write it here as well for you, if you want to register. Secret code. No, sorry, not David. Everyone. Secret code is this. So register now, because we're probably gonna change it by tomorrow. I'll give you 3 minutes. All of you want to register, so that we can do it correctly. Okay. We have been going for 50 minutes now. Any other questions?
No, sorry.
Anyone has questions while we're doing this, or everybody is asleep?
No.
Asleep is a completely fine way to be at the moment. So if no one says anything, I will assume that you're asleep, all of you. Okay, I give you 1 more minute.
I was just registering. Thank you very much. So I still have tons of open questions, but these I will get step by step.
All right, cool.
Thank you.
Bye.
Bye.
I just registered. Thank you.
Yes, cool. Rodolphe. All right, let's move on. Let's go back to look at the documentation. So documentation again is dev.zenroom.org. First, we have the design code basics. In the given phase, we explain so the given phase is about reading and verifying input. So whenever you pass something to Zenroom, you have to pass it in the given phase. The given phase is a read-only execution part, meaning that it's going to read data and it's going to pump it into the next step, which is the when phase, which is where the computation occurs. And after all the computation has occurred, finally in the then phase, the output will be formed and arranged and sorted, and will be given out to the standard output. In the given here in this part of the manual, we learn how to read data, so how to import and read data. We learn what kind of object types Zenroom can take. So we have first we have simple objects, which we didn't call variables because they're not exactly the same thing as a variable in a regular language. We call them simple objects, and each simple object can have an encoding, which is more or less like a type, but not exactly. So, for example, here a simple example of a simple object is, well, a simple example of loading a simple object is, given I have a string, name my string. Now imagine that instead of string, you could have, given I have a number, or given I have a base 64, name whatever you want. So this is how you load a simple object. After that, we have complex kind of objects that can be arrays. Arrays, if you are a programmer, I guess you know what an array is. A schema, which is a complex object with a pre-configured structure, let's say. So schemas are for example, key pairs. So a key pair is an object that's where the father must be called key pair, and it has two children called private key and public key, which are two cryptographical numbers by default in base 64. If you change this to something else, like to my key pair, or if you change private key to like my private key, the keeper will not work anymore. So this is what we call schemas, and we have several of them. Dictionaries, it's something that it didn't make in the documentation today because we're doing a round of bug fixes, but dictionaries are complex arrays where you have, they are arrays of objects where the objects have the same structure. So for example, you can have an array with the log of 10 different transactions, where in the transaction you have the user ID, the amount, and the timestamp. And dictionaries you can use to load them in batch, and for example, to find among the 10, the transaction that was done more recently based on timestamp, or the transaction that had the highest amount transferred or the lowest amount transferred. And you can also do arithmetical operations between objects. We do load arrays in the same way as regular objects. So given I have a string, name my string, and I have an hex array, name some hex array. So when you load arrays, you have, based on the content of the array, you have to give it an encoding. So you can have hex arrays, you can have string arrays, you can have number arrays. Based on what you have inside it, you specify the type of array. Those are schemas. All right, how do you read stuff from a flat JSON? Imagine that you have this JSON that contains my number, my string, and this is an array. You load it like this. Given I have a string named my string, which is this. Given I have a number, named my number, which is this. If you want to load the array, so this is a string array, you would have written, given I have a string array named my 5 strings. That's how you load it. Good. If you have a nested JSON, Zenroom allows you to load JSON files nested up to 2 levels, meaning that you can have, inside your JSON file, you can have father, child, 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 other father, other child, other child, other child, third father, third child, third child, third child, something like this. So here you have that we have a father called Alice that starts here and ends here and contains all this stuff inside. It contains a key pair, which is still considered a single object. And then it contains a number, a string, and an array. And then we have another object called my second object that contains another number, another string, and another array. How do you load this in Zencode? You do it like this. And given I have a string named the second string inside the second object. So you tell Zenroom, find the second string inside the second object. And that's as far as you can do. So you can tell him, given I have a string, name this inside that. You cannot do inside, inside, inside. No, that doesn't work. So you can only have a 2 levels of hierarchy when loading files. And I think that this is pretty much everything I have to tell you about the given part. This is just more examples. Then here we have the manual about the when part, which is the when phase, which is by far the most complex. It is so big that I had to divide the statements in groups. That divided in 4 groups. First is data manipulation. That contains statements that do arithmetic, append an object to another, rename, insert, remove, split, randomize, create strings from scratch, pick a random element, or flatten an array. Pablo Sancho, was it you who asked us forever how to hash an array? Or am I confusing you? Or am I confusing with somebody else?
Well, when I started with, first of all, I would like to say that I'm delighted with this tool and with this level of documentation. Is right now is really, really fantastic and really well formed. And this was when I started with the Zencode in started point. And I had some problems to understand the Zencode basics. Yeah. But now it's completely clear. This is a fantastic tool. It's amazing. And congratulations, it's fantastic.
Thank you very much, Pablo. When you started, all my hair was black. Now I have gray hair because of the documentation. So now you know.
Yeah, thank you very much.
But was it you who has been asking us how to hash an array?
Yes, exactly.
Cool.
Yes, sorry?
Yeah, cool. So now I have an answer.
Oh, yeah. Mm-hmm.
Now I have an answer.
Right. I saw some samples, but I was not so easy for me to find without the former level of documentation.
No. But when you ask me, it wasn't possible.
Yeah.
That's something we introduced, I think, 2 months ago, and the documentation I wrote it 3 weeks ago. So this is the first time that you can hash an array. Actually, it will make sense to do an example about this now. In order to hash an array, you first have to flatten it.
All right.
So this works like this. Okay, basically, in the documentation of the when phase, I have grouped the statements into logical groups. So we have manipulation, which is the one I've just told you. Then we have create random objects, where you can create, well, we showed an example of creating random objects, and set, which you use to change the encoding of an object. So for example, if you receive something in base 64 and you want to convert it to hex or binary, use this. Then we have basic cryptography, hashing. So we have basic hashing, the hashing a number to a point on a curve, which is actually, this is what is used when you want to make a public key from a private key. Then we have more hashing, even more hashing, even more hashing. And this thing that you probably will never need directly, but we need it ourselves. Then the fourth group is compare strings. Compare if objects are equal, more or less, or see if an array contains an element. So verify equal, for example, when I verify that my equal string is equal to my non-string, and here you can do it, work with simple object of any encoding. So if you have an hex here and a hex here and a binary here and a binary here, it's going to work. Then you have less, more, equal, which obviously only works with numerical values. And then actually, I'm not sure. It may work with strings too, although it doesn't make any sense. Then we have found, not found, when my 10th string is found in my 4th array. This is also pretty self-explaining. The way we did put together this manual is that for any group, you have a list of the functions that you can do, and then you have a long script with examples. Now, everything written here is searchable. So if I search for flatten, it does not always work, but it should, let me try again. It should be searchable. No, it's not. We'll look into this. We grouped together this thing. It was searchable last time I tried. Yeah, okay. It finds this one for some reason. Maybe because there is a dot in front of it. I'll look into it. Anyway, we're gonna make it fully searchable. All right, so we grouped the scripts where we explain in the beginning, we give an explanation of what each function does, and then you have an example of the scripts with comments. For the special case of when, what we did is we create a gigantic JSON file, which is this, that you can copy into an object like this. Then we separated the given part from the when part, and basically the given part was just written so that it could load everything that is in the JSON file, even though it wouldn't be used. And then you can attach the manipulation section, the when section, to the bottom of the given phase and execute the script. So if you do, basically, if you save this JSON to a file, then you create a .zen file or a Zen code file where in the beginning you put this part, all the stuff here, down to the bottom, down to here. And after this, you paste this, all right? You should get it to work. Actually, you know what? Let's give it a try. Because nothing works better than try things out. So this, we say we want to call it my large nested when JSON. Right. Copy. Bank. Do I have it already here? No, I don't. So nano. And I copy this and I paste it here. No. Yes. Yeah, actually, I actually did copy it. Yeah, because the last thing is an array. Yes, all right, good. So Control X and Y. And now I have this thing called my large nested. Let me see how big it is. No. My large, yeah, it's 4Ks. All right, so I have this. Good. Then I wanna create a Zen file. Let's call it nano test when one.zen. And what I'm gonna do is I am going to paste the whole given section of this page first. So first I do this, yes, and then I paste this thing. I paste the gigantic script that is after manipulation. All right. Here we go. Then print all data. Control X, Control Y. Good. Now I do Zenroom minus Z. What was it called? ls test when. Okay, I'm gonna make it full screen because it's gonna be big. Zenroom minus Z test when minus D to load a JSON file. My large, yeah, here we go. And then I'm gonna use again JQ to prettify the output. Otherwise it's gonna look very ugly. And let's see what happens. Invalid minus D. Why is that? Minus D, minus C, minus A, sorry guys, sorry, haha. I wanted to do this. I wanted to pass it some data and I made a mistake. So it's not minus D, but it's minus A. All right, good. So this is the output. Now, Pablo.
Yeah.
This is the flattening of a whole bunch of stuff that you see here.
Oh,
so
excellent.
this is the output of the script.
Excellent.
This is the output of the script that that we launched. It does also manipulation. The whole script used 600 Ks of RAM, and it generated all this stuff. Yeah, we don't want to go through it. I mean, have a look at it later. Have a look at it later. But based on the names, I try to make the name as self-explaining as possible. My 12 string to be hashed, hash me to, no, okay, this is not being used. But anyway, this is definitely the flattening of a lot of stuff. Serialization of all data. Pen insert, flatten, yes. So, when I created the serialization of data, so here it is flattening everything that is in the stack at the moment, and is putting it into an object called serialization that I then rename. Okay, let's look at the example that Paul was thinking about. Let's try to hash an array. Okay, and I'm gonna do this using this tool. So first thing I'm going to do, I'm going to create an array. Let's just do it like this. I don't need to be Andrea. It can be that I have no name, so I write given nothing. Good. When I create the array of 10 random objects of 128 bits, and I want to rename it. When I rename the array to be flattened. Here I find another bug. Yeah, all right. This shouldn't be this color. Anyway, object to be flattened. Right, then print all data. Good. Okay, so I have created this array that for now I'm gonna keep it inside Notepad. I'm gonna keep it here, right? And I'm gonna use it in my next script, which will start with, given I have a what is this? This is a base 64 array. Yes. Given I have a base 64 array named, what was it that we named it? Ah, it's here. It's still here, huh? So nice. Control V. Okay. When I flatten, when I create, so you see how beautiful the autocomplete is. I was gonna write it wrong. I basically just guessed that there was a when, there was an I, and there was a flat. When I flats, and it's recommending me to use this. So when I create the flattening of this thing, let's first print. Let's go step by step. First, we flatten this array, and then we're gonna hash it. All right. Then print data. We don't care. We just print everything, and we do paste this into here, into data. Paste. Right. Play. What is the issue?
You have a double when.
Where?
Yes. In the first
yes. So true, my friend. Here we go. Then print, okay. Then print data is not good enough. I only wanna print the flattening, and I wanna rename it first. When I rename the flattening to my flattened array, then print the, then come on, then print, here we go, my flattened, wow, it did guess it from here. All right, let's try that. Here we go. So this is my flattened array, which I'm gonna copy in here. But let's go one step further. So let me do copy paste in case we lose all of this, which is not gonna happen. So now we have to hash it. Now we have to hash it. So we have created it, we have flattened it, now we have to hash it. So I'm gonna do when I create the hash of, here we go. Pedro, you have several options here. So you have this that uses a default algorithm and this that lets you choose. Should we do SHA 512?
All right.
So my flattened array using 512. Then print, okay, if we leave it like this, it's not gonna print the hash because the hash is gonna be called hash. Let's give it a try. Yeah, here we go. But if I say then print data, it's also gonna print the hash. Here we go. Here it prints everything. Actually, what we want to print this time is let's say we only want to print the flattened array and we want to print the hash. And the hash, we're going to rename it. When I rename the hash to my hashed array. And then we do, then prints my hashed array. Yep, here we go. All right, let's do it. Let's create an API out of this. So I'm going to create a service that all of you guys can use. You just send it an array and it hashes for you. That's the way I do it. I press create API. I press create API. Actually, no, yeah, that's fine because I'm not creating it. Yes, perfect. So I must be logged in. So true, so true. Let me see if I can retrieve my password somewhere. Give me a second. So copy password. Yep. Login, Dyne.org, and paste. Let's see if it lets me log in. Yeah, here we go. Create API, and I call this flatten an array. Right. All right. We have this data here. Let's go to my contract. I have flatten an array. If I try to run this, it's going to complain. It's going to tell me I have no array. Zen code Lua given I have a base 64 array. Not going to work. All right. So how do I do this? I copy this stuff. Well, no, I do it even better. I generate another array just to make you to show you I'm not cheating. Given nothing when I create an array of 50 random objects, then print data. Play when I. All right, here we go. But the array has to be called, it needs a certain name, right? Flatten an array, yes. The array needs to be called this, object to be flattened. Good. And I rename the no, it likes only when I do when I rename the Control V the array. Good. All right, so I have now created this. Copy, go back here. I go to Swagger. Dyne.org flatten an array. Try out. I paste it here, this gigantic array. Here we go. I do execute. And here I have my flattened array and my hashed array. So this is the hash, this is the array. And here I have the curl. Okay, let me copy it manually like this. Copy. And I'm gonna paste it here. JQ. Here we go. And you can do the same. I'm gonna paste this gigantic curl in the window here, so you can try yourself. Okay, guys, I have been talking for 1 hour and a half. Let's take one more little break. Anybody has questions?
Yeah, if you want to concatenate a series of given, then given, when, and then concatenate one the only way to do so is using JavaScript.
Maybe try and do an example. What is
Well,
that you're trying to achieve?
Imagine you want to create Now, when you have, for instance, obtained the hash array, then you want to connect to another one, to another scenario.
Yeah.
The only way to do so is just concatenate it in a script.
Yeah, you create a script. Yes.
Yes, and so
so in reality, this is not true, because if you have the limit here, the only limit is the fact that you can only pass 2 parameters. But if you have all the data already, then you can organize it together, put it here, and make the script as long as you want.
Right, but then you cannot then again obtain a hash array then using as an input for another scenario.
Well, actually, you can load more scenarios at once. You can also do scenario credentials. Hello, it's still gonna work. You can use more scenarios at once. Am I answering your question?
Yes, so imagine from given to then is forming part of the first scenario, then I can have another scenario referring variables from or objects from the first scenario, if they are in the same, let's say, script.
It is possible, because you see here I started with given I have a base array name, but I could have created it here. I could have said, when I create a random object, when I create the...
No, what I mean, imagine you are creating this array in the first scenario, the scenario ACDH. Is that possible? You are concatenating, and the second scenario is can use the objects created in the first scenario.
So the scenarios are basically components of Zenroom that are loaded at the startup. So once you have loaded those, you can use all the statements contained in the scenario in whatever you want. So if you want to do, for example, if you want to use the hash, now I have to think of an example.
Yes, imagine you create the object to be flattened.
Yeah.
In the first scenario, and then use it in the second one.
No, that is fine. That you can do. That you can do. So what you can do, for example, is that you can create. So you can create. Given I am Andrea. When I create my key pair. When I create the flattening of key pair. That should work too. When I create the flattening of key pair. Let's see. When I rename the flattening, I have to rename it because otherwise it's going to be all written. The flattening to flats key pair. Let's see if this works. What did I do wrong? 111. Let me see. If we want to look at the errors, we have to go into the console for now. But we're building a version that shows you the proper output here. When I create my key pair, it doesn't like this. So I made a mistake here. Let me see. When I create the key pair, not my key pair. Ha. All right, cool. When I create the key pair, let's see if this works. Yeah. And then print. Print flat key pair. Yeah. We have it.
Right. No, what I meant is this forms and a scenario is like, let's say, a unit of work. Okay.
No, no. A scenario is a component of Zenroom, built in Zenroom, that is loaded. For example, if we look at the scenario petition, which is this, in order to run several of these smart contracts, you need to load two scenarios, credential and petition. You understand? Imagine that a scenario is a plugin that is built in Zenroom. And a plugin contains the interpreter for a number of statements. For example,
oh, right. It's like an import of other languages.
Yeah.
Something like that. Okay.
For example, when I aggregate the verifier is inside credential.
All right.
But when I verify the new petition to be empty, this is inside petition. So
right.
here I'm creating stuff with one scenario and then using it with another scenario.
All right. So is something similar, like an import or?
Yeah, exactly. It's exactly the same as import.
What I meant is, imagine I want to do a sequence given when and then.
Yeah.
And I want to use the resulting objects of one script to a subsequent script.
Yeah.
The only way to, let's say, do pipelining or do a pipe or a concatenation of these executions is only by scripting.
Well, here, as you see, I am creating an object, then flattening it. So this is already, if you like, it's already to scripts. It depends on what you want to do. It depends on the data you're working on.
Yes, what I was thinking is a scenario we saw in not a scenario, sorry, the example we saw in GitHub that was created a credential and interchange, and there was a sequence of different scripts concatenated, different send code concatenated to create a.
Yeah,
that's
right.
I was confused that with a scenario. It's not.
Yeah. Okay. All right. So this here I can. All right. Before we jump into this example, I was showing you the manual of Zenroom Basics. So given, when, then phase. In the when phase, the then phase is very short. Everything you need to know is that you can print an object with a different encoding.
All right.
So for example here, then print the flat keeper as bin. You see?
Mm-hmm.
That's basically most of what you have to know about them. Yeah. This is very short. Then the next section would be Zen Code Advanced. And here you have the explanation of the scenarios. So first we have a chapter about cryptography in general that explains the different kind of cryptographies done in Zenroom. Then we have credential, ECDH, petition, DP3T, which are the 4 scenarios we have now. Let's look at credentials. So credentials contains zero-knowledge proof and attribute-based credential flows that come from the Coconut. They come from the Coconut paper. And if you scroll down here, you will have, if you scroll down here, you see a whole flow scripts numbered 1 to 6 or 7, 1A, 2, 3, 4, 5, and 6. Here we go. Yeah, and 7 actually. So in those 7 scripts, which are actually 8, you have the creations of a keeper for the issuer and for the participant, which is this. Then the issuer also creates an object called verifier. Then the participant Alice asks the issuer to sign a credential, which is given that I'm on as Alice and I have my valid credential keeper. When I create the credential request, then I print my credential request. This is sent to the issuer. So this is the output. This is the credential request. This is sent to the issuer that signs it. After it is signed, Alice aggregates it with its own public key. This is a cryptographic operation that needs to be done. After Alice produces an anonymized version of the credential called proof that changed every time, but it can always be matched back with the Alice credential. And anybody that has access to this data, anybody on the blockchain or in this flow, can match that Alice proof was produced by the issuer, by the hacker. If you scroll down to the bottom of all those scripts, there is always a section called the script used to create the material in this page, which is this. And it says, all the smart contract and the data you see in this page are generated by the script. There is a link. All right. In this case, it's this one.
So the case, and my question was, the only way to just concatenate or pipelining different Zen code is just using scripting.
Right now, yes.
Okay.
But I'm sure that we can find a clever trick to do it with here. Because here, if you look at this, we have different APIs online. So you can start by, you can make a shell script that pulls stuff from here, that generates a key pair, then does something else, and then it curls it back to this. And it takes the output back and it does something else.
Okay.
So you can create a flow, locally or using the service.
Okay, right. Thank you.
Yeah. If you want, I will show you this script. So here we see all smart contract of data you see in this page generated by the script. If you want to run the script, you should clone Zenroom, install ZSH and JQ, and then download the binary and run the script. I have done all of this before, obviously. So I can run the script for you. This is inside Zencode credential. So cd Zenroom ls test ls Zencode credential. Here we go. And here we have a script called run.sh. I'm gonna run it now for you. Oh, script 36, interesting. 28, huh, all right. But anyway, here we've gone through the whole script, and this is just the output. And the outputs have been saved into files every time. So for example, here, create the credential key pair is output to this file called credential participant keypair.json, which goes inside the Zencode cookbook. Okay, cool. So we have 20 minutes left. I guess that I am a little bit tired and probably all of you are asleep. Actually, we were 15 people, now we are 13, out of which 2 are colleagues. So yeah, but I'm not surprised that most of the people is running away. All right, the very last bit of the advanced part are the scenarios. So the credential scenario is where the zero-knowledge proof and attribute-based credential are stored. Then we have the ECDH, where ECDH stands for elliptic curve Diffie-Hellman, where you can do, well, you can generate a key pair. Then you can do symmetric, well, this is asymmetric encryption. So encrypt a message with public key. Then you do symmetric encryption. And here I create an example of how to encrypt and decrypt a JSON object with a public key, which goes through transforming the JSON into a base 64 string. So you have to do a little bit of work. But we have, I got this gigantic JSON file from somewhere, you transform it to a base64, and then you feed the JSON, the base64 to Zenroom. You have to create a JSON file where this base64 is encapsulated into a message. Obviously, this can improve in the future. Can be improved in the future. And then you load the key pair, and here I am encrypting it for the first recipient, which is Bob, and then for the second, which is Carl. And the output is this: secret for Bob, secret for Carl. So I have the same JSON encrypted for two different recipients, and you look at the text, it's very, 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 very long. So that is the encrypted JSON file. And when you decrypt it based on the private key you have, you will decrypt one version or the other. Yeah, all right. So this is the decrypted stuff, and then you have to go from this, which is base64, to JSON, and you get back your file. Then there is create a signature, ECDSA, as Alberto taught me yesterday, where you can sign an object and you can verify the signature here. And then in the end, we have the symmetric encryption. Yeah, that was the ECDH. The petition is something that we did, and we didn't really anybody would be interested, but there is a certain amount of interest in this scenario. So what this allows you to do is to create a cryptographical object that we call a petition, that participants can cryptographically sign progressively in a way where the participants can be completely anonymous, but after the signed, you can tell if a certain participant has signed already or not, so you can prevent double signature. And so far, this has only been done for to be used in a petition situation. So to be used in a situation where people would only sign or not sign. But this can easily be extended to encompass a regular voting situation where you have a list of candidates and you want to pick one, and you want to store it cryptographically. So this could be the base of a voting system, a voting technology that is cryptographically proven and can be completely anonymous. Yeah, everything is here. And also here we have, again, we have a script that generated all the stuff here, which is into Zencode petition. And it says, in order to run this, you first need to run the credential script, which is the one I just showed you. I'm just going to run this for you just for fun. So CD, now we're going to go into this one. CD Zencode petition, and we run the scripts. Here we go. So create the petition. This is the output. Approve the petition. Sign the petition. Aggregate the signature. So basically, you can, every person that signs will produce a signature, which is this, and then the signatures need to be cryptographically aggregated, meaning that they need to be homomorphically summed to the other signatures, which is going to create a ball that grows with a bunch of signatures inside, where you can see if a certain public key has been used to sign the petition or not. And in the end, we have the tally, which closes the petition, and the count. And the count, the result is 1 because we only produced one signature. So this was the petition, the last one, and then I'm done. is the DP3T proximity tracing. That's something we did in the Corona peak of the craziness, and it implements the cryptographic scheme that the European Commission supports for Corona, which is called DP3T, which you can Google. And it's very simple. It has very few statements, which, yeah, pretty simple, pretty self-contained. So if you're into proximity tracing, you can have a look at it. Yeah. Also there's one. Also here we have a script that produces it. Okay, and I think that was it, unless anybody asks questions.
I guess I would like to just clarify the question I had from the previous part.
Sure.
Regarding the storage, because I see the whole zero knowledge thing where I can, for example, put in a number, get a challenge, and then produce, true that I know something.
Yeah.
But if it's something that requires a state, because in my head, smart contracts, all these tokens and storages. So how does this tie up with the, with the blockchain and states in this context?
Gotcha. All right. So I did this thing here. I didn't really go in details to explain how it works. In reality, in the front end here, we have a React.js application that executes Zenroom WASM in the browser, while in the backend we're using this. We can only see here for now. We're using this baby called Restroom MW, and the name is a little bit unfortunate, but we had to combine the word rest with Zenroom, and we couldn't think of a better one. Anyway, here you have the documentation, and what Zenroom does, it takes a smart contract and it creates an API out of it. Next to it, it allows you to extend Zenroom. I'm gonna copy this to you in the chat. It allows you to extend Zenroom with here we have extensions for Redis. Okay, so if I had a Redis database inside here.
Mm-hmm.
Connect, right. Inside here, well, not in the front end, but in the back end. So here I could do I think it's in the then section. I'm not sure because I've never tried it. Anyway, at some point here, you could do something like this.
Ah, okay. I have a valid Redis connection, and my Redis is running locally, right? Or it's running on.
For example, I've never tried it.
Okay.
But you could do this for Redis, and we have the same thing using SQLize for all the SQL databases. And I have a database connection, and I select this from where, and I save the result into a database. And we have in the work an extension from Mongo.
Mm-hmm.
Next to it, we have this. And I'm gonna paste it in the chat as well. This is our blockchain interop layer. So basically, Zenroom can do the cryptography of several blockchains, and we also have the connectors to the chains for several blockchains, which are Bitcoin, Hyperledger Sawtooth. This is in beta. This is a lie. No, sorry, no, this is true. This is a lie. And then here we also have Tendermint.
Mm-hmm.
Yeah. but this would be, we don't have it yet as a component like this that you can script, but we could make it happen for any of these blockchains that you see here. So Sawtooth not yet, but Bitcoin, sorry, Ethereum not yet, but Bitcoin, Sawtooth, and Tendermint we can.
So basically, once I have some sort of state, I can hash it and store on a blockchain or locally in a database, and then from there,
yes,
to continue. Okay, okay,
correct.
understood.
And consider that the documentation of API room, it went online today. So this is the very, very first webinar we're doing, and we've been doing it only with the people in the channel and in the newsletter. So this is going public today. We don't yet have all the examples we want to have, but we have a man working on putting that together examples for this, as well as writing the component to read and write data to Mongo.
Oh, cool. He's a good man.
Yeah, he's a very good man. Very good man. So if you keep in touch and if you come back in a week or two, we will have an example.
Oh, fantastic. Yeah, great project. Fascinating. Have so many interesting components. Thank you very much.
You're very welcome. Yeah, but right now, anyway, if you use Zenroom as a command line, then obviously you can save the output to a file. Whatever you can do with bash scripting, you can do it here. Or you can probably, you can do a bash script where you redirect the output of Zenroom to a Redis table, I guess. Or actually, we have something else. We also have this. Documentation. We also have, if you look in the documentation here, we have Redroom, which happens to be Zenroom built as a library for Redis. So basically, from within Redis, you can perform cryptographic operations like this from within Redis. Set path, check path, benchmark, and the beautiful logo.
Oh, so like directly from the Redis CLI, yeah?
Yeah.
Oh, okay, cool.
Yeah.
Okay.
So this, well, you find it here in the documentation. This is something that we did about a year ago, and we pitched it to the Redis people, but they didn't really show any interest, so we dropped it there. You need to, in order to use it, you need to build the Redis with a patch that we produced. At least that was a year ago. But anyway, it kind of works. This kind of works. But nonetheless, this tool here, this will very soon be able. So you'll very soon be able to read and write from a database from here. All right. Anybody else?
Yeah, I have some questions.
Sure.
So about, yeah, thank you. For the Ethereum compatibility, you think you have a roadmap? I mean, schedule for being
the roadmap is very fluid. So if there is somebody that shows serious interest in that, we'll look into it.
Okay. Okay. So another question was about zero knowledge proof. Mm-hmm. So can it be considered cryptography that is quantum resistant? I think yes, because you...
None at the moment, but we could easily implement quantum cryptography. We have looked at it already, and there is some very, very nice open source library released by Microsoft written in C, so we could implement it. I'm not sure about zero knowledge proof. I would guess so. Maybe Alberto can reply this question better than I can.
Well, I think that maybe it shouldn't, because some zero knowledge proofs are created, are built using big number integer factorization problem, and that is not quantum resistant.
Yes.
I don't know if all zero knowledge problems derive from integer factorization, or there are some other problems that I don't know for now.
Okay, but Rodolphe, what the short answer I can give you is that we've been looking at quantum cryptography, and it is we could implement it with relatively small effort. I don't know exactly what can be done with quantum cryptography. I don't know if we can just do asymmetric encryption. So I don't know, because you're not asking the question to the right person. If you drop me a line later, I'll pass it to Jaromil, and Jaromil can reply to you properly. Well, why are you asking about quantum resistance at zero-knowledge proof, if I may ask? He did run away. Rodolphe did run. Oh, okay, he's back in. Yeah, Rodolphe, I think you were disconnected for a second. All right. Rodolphe, are you back?
Just connected back. Yeah. Thank you.
Yeah. Can I ask you why you're interested in quantum resistant at zero-knowledge proof?
It's for blockchain security feature, you know. So if you have a cryptography that is quantum resistant, so you can make a blockchain completely private and secure.
Yeah, but the question is, do you have today someone that would pay for that?
Someone that would pay for that. Yeah, so it turns to another question, and I wanted to know, so you have a license that the people pay, or you give this work, it is financed by the European Commission? It's free to use, or there is a license for you, for your work?
So Zenroom is licensed as AGPL3, and it's open source. Meaning that if you use it along with software that is open source and released under licenses approved by the Free License Association, then you can use it for free. If you use it with software that is licensed with other licenses, or that is closed source, then we have to relicense it to you.
Okay.
For a fee. So if you use it together with something that is Apache 2, you can use it for free.
Right. Okay. So to answer your question about if there would be somebody interested, yeah, I think it would be great as a tool to facilitate smart contract writing, and if it's compatible with multiple blockchains. So that is a great tool. I think that you are making is fantastic. But the compatibility is also important. So maybe.
Yeah, but you have to understand that Ethereum has its own smart contract system, and Zenroom is not compatible with EVM. It's never going to be compatible with EVM. It's competing with EVM. So what we can do is that inside an Ethereum block, we can read an Ethereum block. We can do the cryptography to write it, and inside we can put our own stuff. But the rest of the chain, all the people that are on the chain that don't have Zenroom will not be able to use it. Do you understand that?
Yeah, okay. But you can make a decentralized app, the app, using Zenroom as a framework, let's say, to create smart contracts.
That we can do.
And make it work also on blockchains like Ethereum.
That we can do.
Yeah,
but
okay.
But we cannot have Zenroom executing Solidity. Or we cannot have Ethereum wallets executing Zen code.
But the app built, powered by Zenroom would be trusted enough to work with, let's say, the Ethereum chain. Okay, so I mean, from an auditing point of view, do you also, for somebody wanting to write a commercial app, okay? Do you provide security and audited certification? Does your framework make the DApp secure, let's say, from an auditing point of view, working with other blockchains?
I don't know what you're talking about precisely.
Okay.
I don't know what this auditing requires for the apps. We're not very familiar with Ethereum.
Okay. Yeah. No,
It's something we can look into.
Yeah, I think it's one of the leading blockchain platform for smart contracts. So it's not only this one, but also Ethereum is good to have. Let's say, absolutely, I think.
Yeah. But we are collaborating with Cosmos, for example, with Interchain Foundation. We are collaborating with Hyperledger. So if you ask me about Sawtooth and Tendermint, I can answer you more. With Ethereum, because Zenroom is a competitor to EVM, we're not digging deep into that. So I don't know what the auditing is. I don't know what is needed. Technically, it can be done, but I don't know all the surrounding approvals that are needed. I don't know what they are like, so I cannot answer you.
Okay. Thank you very much for your answer.
Welcome.
Can I ask what you mean when you say that it doesn't execute Solidity code? Because as far as I understand, we compile, whether it's Rust or Ink or Solidity, we compile it to WASM. And as you mentioned, WASM executes in the browser. So it doesn't really matter in what it's originally written, right?
No. WASM is like .exe.
Okay, that's an executable.
It is an executable. So a .exe is built in assembly or binary code, and it's executed directly from the CPU. While WASM is bytecode executed in the browser by the browser. So WASM, you build your application into WASM. So it's like saying I am building it into. It's like saying I am building it for x64 or ARM.
Okay.
Same thing.
I see. So when you say it doesn't execute Solidity, what exactly do you mean?
Solidity it's a programming language that is executed by the Ethereum virtual machine called EVM. Zenroom does not execute that language. Zenroom executes Zencode and Lua. Zencode is the thing you've seen here.
The English version.
This is Zencode, yeah. And Lua.
Okay, cool.
Yeah.
Okay, cool. Thank you.
Welcome. All right. Anybody else? If nothing comes up, then I think it's beer time for me. All right. Cool. Thank you very much, everybody. And I am going to. Are all of you on our Zenroom channel on Telegram? Okay, I'm gonna post the Zenroom channel on Telegram on the chat briefly so you can join, because I will post the recording of this video. So it will be posted on our YouTube channel as unlisted, and then I'm gonna post a link in our Telegram channel. So t.me/Zenroom. All right. Cool. Bye, everybody. Have a good evening. Bye-bye.
Bye-bye.
Thank you. Bye-bye.
Bye.
Thank you. Bye.